Oh yeah, so yeah, diversity. So with that, I try to kind of think about what different types of speech there are, what different types of speakers there are, and how does that reflect on speech technology. Now, for the non-engineers here, so basically all speech technology today depends on having lots of data. So we need to understand the speech signals. And so we need lots of recordings of speech signals to see the diversity of speech signals, and then the engineers build the models to kind of embrace all the different aspects of speech signals in those models. But it really requires that we have all different kinds of diversity included to build good models. But I'll start with the kind of off topic, or not off topic, but a kind of a tangent here. Talk about flow of averages. So this goes back already in the 1950s. In the US, they were building new fighter jets. They wanted to build good fighter jets. They wanted to optimize every part of fighter jets to be best possible. And to do so, they measured 4,000 pilots, the physical dimensions of those pilots, so length and width and eyesight and this length and that length, 140 different physical dimensions of that, and then they wanted to build fighter jets such that, on average, it would be perfect for those pilots. And this wouldn't be a story if that would have ended well. Basically, the jets performed poorly. There was much more accidents with those jets than the previous generation of jets. And most of those accidents were assigned to pilot error. But that's strange. Now they just built new jets which were optimized to be perfect to those pilots. And now they have more errors. The reason is that the average of those sizes, so when you have average length, you know, how tall are people? The average, let's say 180. But that also depends on the kind of country. Here it's lower in Scandinavia. But when you have 140 physical measurements, when you take the average of everything, almost no one is the average. So what they came up with was individual adjustments. So basically they could adjust the seat size, height, and that kind of. And then that's why we have now in cars, we have the buttons where you can adjust the seats, because they realized that very small adjustments to the cockpit of these fighters, you could make it fit to anyone. But if you try to make it fit to the average, it fits no one. And that is now what I would like to do for speech signals. Let's look at a bit of different labels which we can. Oh yeah, this is background really. If you're interested, there's quite nice stories here in those background papers. So in labels, so when you want to have speech data, which would then look at all the different properties of speech, such that it would work for everyone equally well. So the question is, what labels? So to ensure that we have all those characteristics, we need to give them labels, categories. So the question is, what different labels do we need in speech signals to have a representative range of everything? Write them up here. Labels. So, what different aspects of speakers and language would you want to label? So you have a recording of a speech sound, what labels do you put to it?
Speaker ID and language ID.
Speaker ID, so speaker, so who is speaking and the language ID. Which language is being spoken? Okay, that's a good starting point. More.
Why?
Sorry?
Why? Voice activity detection if there is a silence.
Okay, yes. So speech or not speech?
Yes.
Okay, yes.
Why?
Yes, but so well, I know the term, but non-engineers here don't know the term. So activity, yes or no? So yes. So is it speech or not?
Speech signal.
So the speech signal, yes, that's the we need the recording. Yes. So what basically an acoustic signal. We could also have text. But that's the different acoustic signal. More gender. Emotion, yes. You call it emotion.
So what do you mean by acoustic signal as a label?
So so that's data basically. So we have a recording of the sound.
Whether there's a speech, like sound or not. Is that what you mean?
No, so that's the kind of bubble file. So the data, but that's we should call it rather than data. It's a data and labels. So we could have just text as well, but we can have the wave file, so the acoustic pressure signal.
Signal to noise ratio.
Sorry?
Signal to noise ratio.
Okay, so now, yes, about the noise level and trying to translate to the non-engineers.
Fake or real? Type of noise also important.
Sorry?
Fake or real?
Okay, yes. So noise level and type, and then fake or and then fake or real. So that then refers to yes, no. So that's whether it's a real person speaking or a computer speaking.
What is being spoken?
So you mean text?
Yes, text. What is being spoken?
Yes. Text, transcription.
And also timestamp with multiple speakers involved.
Mm.
Like who spoke when?
Yeah, who spoke when? Yes.
Timestamp.
Yes, and this can also both text and then timing.
Timing.
Keyword is
And
speech.
then this also could be timing also here.
Okay.
Keyword?
Keywords, okay? So is that then basically on the content?
Yes.
Okay.
Speech length.
And that's these keywords then basically compresses information on text.
Speech length.
Length. Yes, so I think we can from the timing information we probably can infer that. Sorry?
Overlap.
Overlap, yes, okay. Let's put it here also, overlap. Overlapping speakers. But now let's get more to the personal information. So speaker.
Accent and dialect.
Accent, yes. That's connected to language, so accent, dialect. I write just accent, but it contains also dialect. Age. Yes. Couple of important ones still missing. At least one important one.
Visibility.
Sorry?
Visibility.
Disability, yes. Disability.
The group that the person belongs to.
Yes. Give more.
Race.
Yeah, okay. Yes. So ethnic background. Ethnic background. Other groups.
Nationality.
Lab data or
Nationality, perhaps, yes. multiple people saying something.
Whether it is recorded in the lab or audio.
Two minutes at the same time, one at a time. So first, we have something.
I said whether it's human or other animals.
Human or animal. Okay? I haven't thought about that before. Human, like, human, yes, no. Human. So other sounds, so yes or no, but that's also then related to the noise. What we have the noise that we had already here. Okay.
Machine generated.
Machine
Human
generated.
or machine generated.
We had also fake we had already here.
Audio clarity.
Clarity, that's close enough to noise level and type, so other distortions.
Which direction the sound is coming?
Ah yes, so spatial information. So both then direction to the microphone and distance to the microphone, and if you have multiple microphones, then so spatial information about the environment.
Number of channels?
Spatial environment and channels.
Sampling frequency?
Ah, yeah. Technical details. Sampling frequency.
Recording device.
Now, sampling is not important for the non-engineers now.
Recording device.
Device, yes.
Environment?
Sorry?
Environment.
Environment, again. Yes, so let's extend this into two. Spatial and environment. Yes. There was one, sorry?
Storing the signal. Where we need papers.
Oh, where it's stored. Okay, yes. Let's destroy the device contains also storage. There was one important missing was what the disability, but the overall health is important. So I put it here also. Put top health here. All right. It's full already. So I'm sure we can find more. But the point here was not really to have all the labels. It was more think about the range of things which can be useful. All right, and then if we would make, let's continue with the call center scenario. If you would make recordings, let's say Indigo, I flew here yesterday with Indigo, we have Indigo call center. So if we have, for each of these, we have a range of values. So how big a range values do we or if we want to have recordings, what is the range of things we can have? Let's say language. What is the language of Indigo? Which languages should we record to have a call center with Indigo? Sorry? English, yes. Yes. Okay. English and local. And local. Good. Let's say, for example, genders. What genders should be groups we include? Male, female. Sorry? Trans, yeah, okay. So there's lots of them. Let's say, I now, as a placeholder, not to diminish anyone, I just put the placeholder others here. But how do we go about labeling those? So I think someone said self, I heard self. That's wishful thinking. I heard self-identified gender. And if we do that, we end up with, let's say, 30, 40 categories. Right, next one, accents.
American accent,
So,
American accent.
yeah, so
Talking, running.
how many?
It's so many.
But so we are engineers now for Indigo. How many we target? Sorry, speak out so that I can hear.
How many accents?
Yes, how many accents?
In this country, at least 100.
100, okay. And how many are in India overall?
This is in India.
Depends on the language. Actually, you cannot have 100 accents. It depends on the language.
Yeah. So there's the number of languages. So I heard that. So you are the locals, I'm not, but I've heard something like 1,400 kind of different things.
Different languages.
Yeah. So how many of those do we then cover? So collecting 1,400. That is expensive. Expensive. How many do we say percentage? 10%, okay. So it's 10%.
No, we have only 22 official languages.
Yeah.
22.
We
In
have
that,
254 official languages.
official.
Schedule and
Scheduled languages 22.
Well, so yeah, so let's run with 10% just as a. It's not a real number. It's a simulation. Age range. What? So now, what is the range of the people you want to record?
10 to 30.
So you think that 0 to 10 is customers that we want to record?
above 18.
Sorry?
Above 18.
Okay, 18 is the lower range. I can buy that. What is the upper end? So you would want to record 99-year-olds.
They would need travel.
So
18 to 60, 60 to 90.
yeah, okay, let's see, 60. That sounds like a possible, practical recording scenario. It's usually hard to get hold of older people, but of course the range does go to, say, hundreds. So if we have now 18 to 60, how many percentage of the population is that? The majority, perhaps, yes, but it's so 40% of 100, but it's probably more people here, so let's say half the population. So 50%. Disability, let's group disability and health. So do we record healthy people or do we also record sick people? Both. How do you get sick people to get recording?
Go to the hospital.
Go to the hospitals. Do you think that Indigo would do that? Go to hospitals?
And third parties data provider.
So let's say in a realistic scenario, only healthy people. So and how many people are really healthy, like on average? How big a percentage? Any guesses on that? So now I read somewhere. Actually, I asked the AI for answer on how many people are healthy, and it said that usually they count about 70% of population is more or less healthy. Of course, that's also a degree. Like I have a small speech impediment. So the question is whether I'm healthy or not. Or then if you have a slight flu, are you healthy or not? But anyway, we'll say 70% here. Human, Indigo customers are human, I would say, that we don't record anything else. Emotion, how do we, should we have neutral only or also other emotions?
You should have angry just in case someone loses their baggage in the car.
Yeah, okay.
So
So,
it
yeah,
should be high priority.
so neutral and angry. Okay.
Depression.
Sorry?
If some person is depressed, in depression.
Depressed. Okay. Yes.
Happy, if someone is
Happy. Okay.
Happy to call also.
Sorry. And so the question is then how do we get that data? Is it realistic now that Indigo would collect angry and happy and sad? No.
They will automatically identify. I think there should be some instruments, some programs. People call, they will not know whether it is a special category for happy people or sad people,
Yeah.
isn't it? So automatically that speech recognition algorithm should identify, and then it will route the calls to different teams.
Yeah, but so yes, but so if you have something automatic, then it's a computer behind it, which does the categorization. So then we need to have data to train that categorization.
No, so that past historical data. They
Okay, so you would use past recordings, and that is plausible approach for many, although at least in Europe it would be problematic with the GDPR. Basically, unless you say it and in advance that they are recorded, and there should be some sort of opt-out as well. I don't want my voice to be recorded. So yeah, but so anyway.
Call centers have those
Yeah.
type of. So if some keyword is there in that speech, then use something to classify it as, happy sentence or depressed or sad or
Yes, so
argumentative.
if you have transcriptions, but then that's
First level, what they do is please record what you want. From that, get
Yes,
the
but so-
intelligence.
But so if you have transcriptions, then you have already handmade speech to text, which should already have been trained on that. So there's a chicken and egg problem. So if your training data for the speech and text did not include angry in the training, it will be poor at finding the text, and then will be poor at labeling angry. So I would say that usually people or engineers record just neutral sounds, not emotion categories. And at Indigo, how many percentage of the users would be in neutral state? Just as guess a number. 60%. Okay. Emotion 60%. We should look at noise. So when they call Indigo, they probably often are at the airport, sometimes at home, or so we need to have some sort of noises. Let's say we have like silent airport, we have home, office, street, car. Yeah, that's six categories. How well does that cover all the categories where people call Indigo?
Maybe a ranking from say 0 to 6, if it falls within that.
I think we can get quite high number here, so something like 90% of the different environmental scenarios we can get there. Text and timing keywords are not perhaps now for this analysis important. I'll get to the goal in a short while. So ethnic background. So that's now different than the language and accent. So someone I could stay here for 20 years and then I would have that local accent more or less, even though my ethnic background is different. Also, I could call Indigo right now and not match any of these categories here in the language or local things. That's actually, we didn't think about that. Indigo users, yesterday I think I was the only kind of white on the plane. So that makes about 100 people, so 1% outsiders. Probably not a big effect here. Anyway, ethnic, so if, and nationality, does it make an influence when we all look at the language and local like accents? I don't know if it's, now for Indigo makes a difference. Sorry? Yeah, but that was only, so we have languages and accent we have already included. That's all. And does the ethnic background have an independent effect on the data?
So let's say someone who's, let's say, Chinese may prefer speaking to someone who's Chinese so that they understand.
Yeah.
Instead of, that may be a...
Yes, but of course they prefer, but will Indigo make a Chinese interface just for that one in 10,000?
If they have an influx of a certain nationality coming into India very frequently,
Yeah.
then they may be motivated
Yes, that's true. But then they would add that in the language and accent. So we will still get, well now we have 10%, but
yes, but let's say you have an Indian who's talking to the ethnic person, they may not be able to mimic the actual language and accent that the person of the other nationality is speaking in. So that time you may demand someone who's truly of the other ethnic class.
But I think Indigo is a big company, but it probably could accept that it cannot serve all languages. So some compromise has to be made there. Device, I don't think perhaps this example would make much different. There's some technical issues involved, like sampling frequency, which can be different on different devices, but perhaps I don't want to go in that here now. But so the question is now that if someone has a calculator, can multiply all these things together, so 10%, 50%, so that's 70, 60 and 90. How many percent of the population is left now? Does someone have a calculator? Multiply those numbers. Here at least one person. Sorry?
18 crores.
Sorry? I can't hear. Yes, so we should multiply 0.1 with 0.5 and then 0.7 and 0.6.
Very minuscule.
3,000.
Maybe
37%. 37.8.
It can't be 30% because we are only 10% here. It should be something like perhaps 1 point something or 3.7 would perhaps be 3.7 I could buy. Could also be 0.3, but let's say so overall 3.7% of the population is now included in the data set, like represented. So if you think about that from the diversity viewpoint, it's not much people in that category which are represented in the data. So if this is our approach to collecting data and to building systems, we start quite badly now. So I don't have really an answer to how to do it better. That's something which you should think about. So what we would like to have is speech technology which works for everyone. we would like to have more data and more labels, even more labels than this, but then we still, if we have more labels, we multiply it with even smaller numbers and we get even smaller percentage. So this is not the complete solution. We need something else. But anyway, we should verify performance then for also the outside these categories, because the training data is then just for a very small part of the whole thing. But so in this example now, 94% of the population is, 96% of the population is outliers, which we haven't basically trained for. When was our lunch break?
12:30.
12:30.
We can continue.
Okay, so I'll continue a bit more. But this is not all. This is if we would somehow be able to include everyone in this, yes, then we could in theory get performance to be equal for everyone. But the question is whether do we want that? Would that be good? We can also think about equity, equality versus equity here. So usually we can think of, so for whom does speech technology work best and the worst? If it's trained to work, if it's trained with this category of speakers, it will work best for that category of speakers. But for whom would this be most important? Who needs it the most?
The less represented.
Yes, so the least represented.
The less represented.
Yes, so the more marginal groups. For example, those who speak language poorly, perhaps those. I forgot one category here. Those who are less educated. So the education is big education level. Those who have lower education perhaps are not so skilled with the phone app or something. Perhaps they have end up in more problems. They perhaps more often need to call Indigo. So they would need it more. Perhaps those with a speech impediment, perhaps they have a hard time at the counter getting service. They would need more call center. Perhaps older person has a hard time moving at the airport. Perhaps they miss the flight and they need to call, so they need the service more. So basically the difference between equity and equality, I had to look this up short while ago. I couldn't remember the difference, but I think this is a good representation of the difference between equality and equity. So if you have equality, everyone gets the same service. Everyone has this card under them, and then the long one will see over the fence, but he could see over the fence without the card as well. But this short guy doesn't get any service. But if we then have equity, we put more effort of the service to the disadvantage. And now all of them get the service. They can see the game. So that is an objective that we could have in speech technology, to focus not on this category, but actually focus on the 94%, actually not 96%. So my conclusion here is that the speech technology trained on these narrow data sets, they actually increase inequality. They do damage, actively doing damage. And that's on we are engineers doing speech technology, so we are responsible for the damage that our work produces. So that's something to think about. how do we solve that? So what can we do then? Now this is perhaps a joint discussion. Any suggestions? What can we do then to solve this?
We have to identify where the speech technology is supposed to be used oftenly.
Yeah. So identify where speech
Identify
technology.
where we are going to use regularly.
Yes. So where the speech technology is used. You have 2 points there. So you said where it is used. So that's like observing actual use. And what else did you say?
So we should have a thorough survey
Yes. Survey.
where people are using,
Yes.
or where the probability is more of using speech technology. So I think those areas we have to identify. There we have to push the technology.
Yes. So that's then kind of observing who is currently using. Yes. But so if there is a current equality or equity problem, so if let's say elderly people are not using service, we wouldn't see that. So we kind of observe only those who are actually using it.
Another important problem, what I think is affordability.
Affordable.
Technology is not affordable to all because there is a diverse set of people are there.
Yeah, that's also something I didn't include here. Economic background, like it should be a big one, but there's no room anymore here. Economic, put it somewhere here with a big font. Economic background. So that. So now to think about Indigo services, how does the also I think the economic background applies is more important in like overall in the Indigo's case. It's not so obvious that what the effect is there because they are you have to buy the tickets. It's the same price basically for all. So the service quality is then. Yeah, I don't see how it connects. Probably is a connection, but not an obvious one. So what can you do?
Rather than focusing on where it is used, where it is really needed to use
Yes.
is the important thing.
Yes. So connecting his thing. So the added here was that where it's needed. Yes. So
Identify the requirement.
yes. So I identify who actually would benefit from it. So and the important thing is that it's not just those for whom it's convenient, though for whom it's very important. Yes. Any more ideas?
Build generalized algorithms that work better, but that are not dependent on the data set.
Yes. So the generalized algorithms which are not dependent on the data set. The question is whether that is enough. That's a one step.
Maybe not biased by the data set.
Yeah.
Data in the data set.
Yeah. And so I don't know, but my kind of hunch is that we need more than that. So we need somehow to develop algorithms which generalize. So let's say that we look at age data. So we can somehow isolate the effect of age, such that it's not when you look at the languages, age is not an issue anymore. So, but we usually these machine learning models are trained end to end, and everything is connected. But we should somehow train them such that we can isolate the effect of different components. That's my hunch, but I don't have anything backed it up.
What about synthetically generating data like for minorities?
Okay, so the suggestion was synthetically generating data for minorities. So basically, data augmentation methods. Yes, that is definitely one of the things we can do. So let's say, oh, sorry. The idea would be that if, let's say we have here, one axis is age, and let's take emotional, accent. So we have here a list of accents. So if we would get, for one accent, we get all the, so this is our data, what we have, and we have also lots of accents on this end, but just for a small group we have, so all the, so this is the area we have of data, and also here a small range. And that, then based on kind of combining this information, we could somehow generate new data, or so synthesize fake data, which comes here on all the other areas which are not included in the data. Yes, so that's basically the data augmentation approach, and I do think that has certainly value, but of course it's then fake data. So we have to somehow verify that it actually works over there.
We can't call that as fake data. We say it as an upsample.
Yeah, also
the existing data.
Yeah, so we can use it many different names with it, but so I think it's useful to call it fake data so that we don't lose track of that. The origins are not, it's not real data. Data augmentation is currently used quite widely in machine learning, and it starts to be that so standard that people forget that it is not real data. You can call it non-real data to satisfy you.
No, but in Indian context, fake means something which is negative. Fake data means something which is negative.
Oh yeah, that's true, yes. So,
So synthetic data we call that.
Synthetic is yes, that's true.
Because if it is fake data, then the scientist will never take that.
But yeah, but so wording is, so the semantics is important here, that we have to keep remembering that it's not true data, and therefore we cannot trust it fully, but it can still be useful. Now we actually we're back again to the trust level. That I don't trust fully the synthetic data.
But then what is the solution?
Yes, so that's one of the group projects. You should think about what is the solution. I don't come with solutions. I come with questions.
The guidelines. You can give me guidelines. Because what you say is pertinent to everyone of us.
Yeah. So,
so we have been blindly accepting that we will do oversampling, and now you gave us an idea that is a fake data.
Yeah. Well,
and my brain cells.
Oh, just so that I'm trying to just activate your brain cells. Yes, but so my solutions here was what we can do also. Someone says that we should study community and societal injustice and effects. So basically, solutions which we named here, and emphasize the vulnerable and disadvantaged groups in training models. So we should give the, let's say, the not healthy data a boost in our training, such that they are better represented, so that they get more benefit. It's mostly a question of how much we boost the disadvantaged populations, because when the when the performance starts to drop for the majority, at some point it becomes too bad for the majority, and that's also not good. Yes. But the question is, like, it's quite academic to just talk about injustices. like who am I to know how let's say take a practical example of so we are here. Actually, I'm happy to see that we are kind of the gender balance here is not too bad. I mean, usually engineers are more, at least in Europe, more engineers are more male, but here we have also lots of females. So often we look at, for example, the gender balance, then that males are often seen as the privileged gender, probably too, and then the females are seen as often, and maybe in situations are with disadvantaged, but not to speak of the other kind of gender categories, they are even more disadvantaged. But so, how would I know what they feel as an injustice? I'm the white male, I'm the privileged guy here. How would I know what, say, transgender feels as injustice in the services of Indigo? So the question is to you, how would I get to know those injustices?
Inclusivity in decision-making body. Inclusivity in decision-making body.
So inclusive decision-making bodies, yes. So yes, those can help. That's a good like component of an organization or an NGO or something. But where do they get their information?
Surveys.
Surveys. Okay. Yeah, that's one. Survey.
Feedback from legacy users.
So feedback, yes. That's very close to surveys, but not quite overlapping. Yes, feedback. More. Well, I get to more here. Okay, yes. So we have actually had this. I get back to this, how to get information. But anyway, we already discussed the accent, language, gender, age, emotion, background. We didn't talk about political leaning. That can also be, for example, in the US, you can see that the right and left they are different. They speak differently. They express themselves differently. We need to have them represented in the data.
Why would that be pertinent for services?
No, this is not for a survey, it's just overall diversity. So let's say an airline in the US, American Airlines, if they have a chatbot, it needs to have both Republican and Democratic people in the
So you
data.
have to appeal to both.
Yeah, exactly. Education level, religious background, health state. I think that we've already covered these in this list. But so now we got to come to the back to what I wanted to talk about, the user experience and preferences. So it's quite presumptuous for me to know what the disadvantaged populations feel as injustices. So we did user studies, and already mentioned here the surveys and feedback. That's one form of survey and feedback. But I feel that often remains quite surface level. You usually have these, many websites, for example, now have, or applications have this, that star rating. How good was the service today? 3 stars. Perfect. Is that really useful for the application developer? So if a transgender calls there and kind of Indigo and then gives 2-star rating afterwards, yes, okay. But so how does that help us making the service better? Not really much. We need some more information than that. So we need to identify first the category of people they were part of and how the service went badly. So we need a much more in-depth interview. And also, well, I feel like every service nowadays has this star rating at sometimes. I find them annoying. So I give them always 1 star, because you are disturbing my experience by your questionnaire. And I know that data is not very useful for them. Makes me angry. If you want to record my voice, then I can have an angry voice for you. So they have to be quick to be useful, to get answers. Otherwise, people just skip them. But that makes them superficial. So they are not useful in any way. So my solution is what we have done in my project where I'm involved is co-design. So we actually invite, so the project where I'm working is to develop speech interfaces at the city where I live, it's the Espoo city. So at the migration services of the city, we want to have speech interfaces to make it more scalable and like have a more wide services for the migrants in the city of Espoo. And now we have invited, let's say, immigrant mothers to focus group workshops where the migrant mothers then talk for like an hour with one or two of our guys about how they experience the service at the city of Espoo. So then we have really close, intimate contact with the actual people using that service, and we get to the level of empathy with them. So we can, on an emotional level, understand how they feel injustice in the service. And then actually the immigrant mothers then are part of the design kind of outcome. They help invent design choices which make it a better service. And by making them part of the process, they also take take responsibility. They feel that it helps them and helps their friends. So somehow they get involved in that stuff. They feel responsible. So it's not just that they are responsible, but that they feel responsible, and therefore they perform much better in the role. And of course, they also need appropriate compensation. So getting a better service from Espoo is nice, and kind of having your friends tell me that now the service is better is nice. But I think that quite often that's not enough. They actually need to be also paid for something like that session. 1 hour of their life spent in that workshop, or more, even half a day sessions. So the really good design of is not just surveys. I see too much surveys. Yes, but we'll get into more of that also. I think it's good. Yes, I think that's the final slide before the lunch. So co-design is service design with the end user as a collaborative contributor or participant. So we don't talk about subjects. We are not operating on them, or we are not like extracting information from them. We are working. They are partners in the collaborative process, and that changes the way of thinking quite a lot. So then you have these workshop interviews and conversation, and the lived experience is something which they quite a lot that like our design team talks about that. So they have already interacted with Espoo City, and they have an experience how it feels to be in that situation. So they can feel the injustice if there is such, and then they can kind of talk about it. And when we get an empathetic connection with that injustice, then it's kind of, we get the responsibility on a feeling level and not just on paper that 10% are injustice. We feel that it's important and we get excited about being able to support that vulnerable group. And also the kind of we actively try to communicate how the participants' contributions now help the design. So often there's a long delay. We have an interaction with them, and then we go back and try to design something, and 2 or 3 or even 5 years later comes a better design out. The participants are long gone by that time. So that's hard to make them understand how much they help the overall design in that sense. If we have a long tradition of designing things, let's say we've done this for 10 years, then we can show that the previous results. So we had 5 years ago, we had this customer interaction or like a participant interaction, and it helped the service in this way. So we made these changes. So that kind of communication to the participants really demonstrates to them that the contributions they have are important for the overall design. Yes, and by kind of getting them understand the benefits, they take ownership of that. And also we take ownership of it when we have the emotional connection to the injustice. All right, I think that's then a good time to take a lunch break. Now, where's the lunch?
Yeah.
So we've arranged lunch at the transit facility. Our volunteers will guide you, so you can come back at 2 o'clock.
Okay, so at 2 o'clock, so 1.5 hours to continue. Good, thank you. Today was the human value-centric speech technology. I will today talk quite a lot about AI and not just speech. So I start first with AI-centric, or AI, or human-centric AI, and then continue with speech included. But overall, so when you look at the noise that left here, when you look at the implementation of AI, again, it has been kind of moving in 3 waves. The first wave was research-oriented, so basically researchers working on AI, so trying to find out what we can do with AI. Is there a problem over there? So, human values-centric speech technology. So I will actually starting with AI in general first, and then kind of slowly working my way back to speech. But the way I see it, and also have heard others present it, is that the kind of arrival of AI has moved in 3, or the current way of approaching AI has come in 3 stages, or is going in 3 stages. So the first wave was like research-oriented. Researchers or engineers basically investigating what can AI do. And then the second wave, where we are currently, would be the business-to-business applications. So within one company, let's say AI analysis of some documents to get answers for the business they are developing, or some other business processes. And kind of characterizing feature of this is that the scope is rather limited. You have defined input and defined output. You know exactly what you give it to it, and you know exactly what types of outputs you want to have from it. So let's say document analysis is a good example, or transcription of medical. When the doctor makes medical notes, those could be automatically transcribed, and we have a limited input set of what types of things can be transcribed, and we know exactly what we're going to have out. And in these kind of situations, the legal exposure is manageable. So that, at least in the European context, we have GDPR, so the privacy laws, and then the AI laws in the AI Act, which govern these sort of things, and we can do things. So the legal frameworks are not too restrictive. But then the interesting part here is the third wave, which is the consumer-facing applications. Could perhaps argue that the large language models are the first part of that consumer-facing applications. Whether they actually do what we want them to do is a different question, whether they're ethical and all that stuff. That's a different thing, but the scope is still wide. But also with ChatGPT and better things, we start to see society-level implications and community-level implications. We'll come back to that, what they are. But one important thing is that the legal exposure is quite unresolved. At least in the context where I work, together with the city of Espoo in Finland, they are very reluctant, or they say, not just reluctant, they just say no. We cannot have AI in government services because of trust issues, because of the legal exposure. And that is something we kind of need to address to go forward.
Sorry, let's get the last point clearly. Do you mean to say Finland is saying no to PUC AI applications? I mean, like.
No, so yes, so not Finland, but individual government officials, like on the city level, they just don't have the resources. So someone needs to like make a standard of how AI can be implemented in the government setting. And none of the individuals want to do that because the risks for them personally or the business unit is just too large. These things will have a society level implications. And that's then hard to manage. So someone has to take responsibility. And who is the question? So of course they now, for example, EU. So now we have the AI Act is in force, I think, from last year. And that sets some rules. But how they are interpreted, that's still ongoing. For example, now I'm participating in a work group which is trying to make like a draft document on how they are implemented with respect to deepfake things. What are the mitigations? How is the law interpreted with respect to deepfakes? There is no interpretation yet, and that working group wants to then kind of lay out the technical background, what is possible, and then there's like a discussion with the government, companies and governments and interest groups and researchers, and so that our document is supposed to be like a inspiration for them, starting point. Of course, it will contain lots of errors, but that's why we want to have that discussion.
I want to ask, so a government official is not allowed to use AI in their work. So what if, can a third party who is not a part of the government like build a language model on public government documents?
Yes, so if they're public, yes. So actually, my team has made just that. We've used City of Espoo documents to do some experiments. But then when they want to do experiments with that, City of Espoo won't put the label on any of it. So it's not a city experiment, it's the university experiment. Because immediately when AI is exposed to the users, there's going to be trust issues and the legal issues as well. So we need to have that sorted out before we go anywhere near the government services. And that's like a very big practical problem that they have the customers and we have the models and they are not allowed to meet. So how can we test things?
So trust, they have to trust you.
Yeah, exactly. So the government currently does not trust AI. The government does not trust us. And that's fair. I mean, I don't blame them. It's not a judgment. It's a fact. This is the situation, and so like I will talk with trust lectures on Thursday. Communication is essential. We need to communicate accurately what capabilities we have and what are the risks and benefits, of course, as well. But it is like that's the state of affairs in my perspective now of AI development and implementation. But then I wanted to introduce the concept of human-centered AI. So within AI research, this is now it's not entirely new anymore, but it now starts to emerge as a sort of the direction in AI research. And as an example of that, it's to think about self-driving cars. So self-driving cars, something like Tesla driving around. They have been driving around in California already for like 5 years at least. And of course the big market, or one of the big marketing ideas of that is that you don't need a driver anymore. So we are freed from that effort. But also then as a practical thing, basically you don't need a car anymore. You kind of just get a taxi and you can at any time get a ride home. So that would be a more efficient use of resources if we can share cars efficiently. And hopefully we could do that with self-driving cars. But in practice, what self-driving cars do is that when you go to dinner with a self-driving car, the people tend to send it home to wait until we are finished at the party or wherever we are, and then they come back to fetch us from the restaurant and drive us home. So instead of reducing traffic, now we have doubled the traffic because it drives twice, home and restaurant and home again. So trying to make it more efficient, we actually make the problem double. And this is a very typical scenario of AI applications, that you are trying to do something good and reasonable, but you make things worse. So that like highlights that you really have to think about the community level and some society level implications of self-driving cars or AI in general, or at the outset. It's not about, so the self-driving cars are not bad, the users themselves are not bad. It's the design of the service which did not reach its potential. Let's see. But so, now this was an example of society level impact. So now should I think a bit about what is society level impact? What does that mean? Of an AI. Can you think of examples of society level impact?
Traffic problems, clogging of roads.
Yeah.
I started using AI, but I'm creating problem for my society.
Yeah. So that is
community.
So this is the example exactly. So that is the traffic example is a clear example. Can you think of other applications, other AI applications, and what the society level impact for that will be? Just throw out an AI service, and we can join to think about the impact of that.
Yeah, let him go first.
Right?
GPT.
Yeah, so you said that's large language models. Okay. Yes. Okay.
So like recommendation systems that Google uses to recommend videos.
Yeah. I think that's large language models. They have lots of impacts, but it's hard to address them now here shortly. But that recommendation system is a good example.
The impact is, for example, you can kind of move the direction, like how a society thinks by recommending the right videos to them.
Yeah. So now you're talking about YouTube videos and how recommendations
Yes.
influence the community or society.
Yes.
So what is the impact of that?
For example, you can get them to buy a certain product if you
So
recommend the right videos.
We should have the microphones here so that the remote people can hear. But so let's repeat it once more. Please.
So recommendation systems have a society level impact.
Yes.
Because if you recommend a certain type of video to a large population of people, you can influence the way they think. And specifically when it comes to, say, buying, let's say, a phone, you can tell everyone that you should buy a OnePlus phone, and then OnePlus will have huge sales,
Yeah.
and so on. So that example can be tuned in various ways.
Yes. So that is the like a business level kind of impact, and so that you can basically choose which companies flourish based on the recommendations.
Yes.
It can also create epistemic bubbles.
Just
Basically, there are those bubbles where, suppose like, if two of us are into epistemic bubbles, I will not know the information that she knows. She will not have access to information that I have. So we'll practically be living in two different worlds.
Yes.
And then we miss out on opportunities of, so probably, getting into a collective and probably solving certain issues. So these issues pertain, there are many other issues that can come with these bubbles, but for example that.
Yeah, so for example, now, political opinions could be...
Can be political, can be health-wise.
Yeah.
So I might think, so now there are these things, 1 week I'll say turmeric heals everything, and then the next week somebody will say, turmeric is harmful.
Yes.
So, these kind of bubbles and
Yes.
so misinformation.
Yes, misinformation is a good word, yes. So misinformation can be easily spread larger if the recommendation system happens to believe it's correct or important. Sorry.
So digitizing local folklore.
Yeah. Microphone.
Digitizing local folklore and lesser represented languages that impacts the society of that particular language.
Yeah.
So
But that can be both good and bad. So that community can better communicate with themselves, but of course then also misinformation more easily spreads in the community.
there are languages that might be dying off in the next few days. Preservation and using that to teach further generations would be an application.
Yeah, so that's a useful society level application. Let's say socially. But then let's bit expand this also to community level. We are a bit already tending to that direction. But what would be a community level impact in difference to society level impact?
Main problem authentication and the trust among the people is also very important at community level.
Can you repeat the microphone, Joey? So also I hear.
At community level.
Yeah.
At community level, any AI application will create a lot of issues related to trust, whether it is trustworthy or not.
Yeah.
So that should be made clear. So definitely it will have impact on community level, specific community level.
Yeah. So can we have a specific example of? Here's an example, perhaps. What is the impact of that or consequences?
Yeah, I just want to give an example. Like nowadays, we can take a sample of any person's voice and we can mimic it. For example, if my mother's voice is mimicked and she was asking for son, I need 10,000 rupees right now, I'm in hospital now. So they have mimicked the voice and the trust, that can be impacted in that community.
Yeah. Oh yeah. So okay. So it's not only the criminal act of forgery or like the scamming, but also it influences the trust in that community.
So I recently read that there was an application where there was automatic judgment of people based on their crimes, alleged crimes.
Yep.
So it was biased towards the black community more than the Caucasians. So that could be a negative community level.
Yeah. Of course, the community of blacks in the US setting is of course a question whether it's some kind of community or some society level problem. But there's no really hard line where to draw what is a community level problem and what is a society level problem. But it is a bit difficult to find good examples of community problems like spontaneous like this. It's more than that. When you do the impact analysis of a specific system, then you start to see also the community level effects of that specific system. Yes, so perhaps I will come back to the community level things. I now realize that